let f be defined by this piecewise function. Determine the value of k for which f is continuous for all x's. Right? Now this piecewise function, the only problem that it really has is at 1. Why do I know that? Because it's given there as breakpoints. Right? So you will be using this piece right here for anything except the negative 1. And you will be using this little piece here, which is the k, the all norm, when x is equal to 1. Now, in order for something to be continuous, we must have f of 1, because that's the only point of interest for us. We also need the limit as x approaches 1 from the right of f of x. And we need the limit as x approaches 1 from the left of f of x. So right, left, and down. If we can come up with values for all three of them, and all of them are equal, we force them to be equal, then this will make it continuous at x equals 1. So what is f of 1? Well, f of 1 doesn't go with the equal sign, that's just k. I mean, we got nowhere to go there, so there it is. Now, the limit as you approach 1 from the right. Now, remember, this is a value right here. Right? This is the one that you need to use when you're coming from the right. The kids get confused because right here it says not equal to a 1. But remember, you're not trying to reach the 1. You're just trying to approach the 1. Right? So, if you're coming from the right, here's 1. So for the 1, the value will be k. But if you're coming from the right, you will have to use this one. So x squared minus 2x plus 1 divided by x minus 1. That's for the right. And from the left, you have to use the same one. So x squared minus 2x plus 1 over x minus 1. So that means that if I'm approaching from the right, I will just plug in the 1 into the right side, which is this function right here. Right? So that's equal to, plug in, and I get 1 squared minus 2 times 1 plus 1 over 1 minus 1. And I can see that this is going to be a problem because I'll get 0 divided by 0. Guess what? That is the case too. So can I do some cancellation? Can I factor? Maybe I can do L'Hopital's? You betcha. So let me do maybe some cancellation. We need to practice with some factoring. So this is x squared minus 2x plus 1 over x minus 1. Erase this to create some space. Factor the numerator. So that's x squared plus 1. That's a plus 1. Negative 2. That's correct. And you can notice that these two will cancel. So when you plug in the 1 there, you will get that the limit is 0. So the right limit is 0. And if we want to force this to be continuous, the right better be equal to the value 2. So that means that k better be equal to a 0 also. So the answer for this is A. I do not have to go and work with the left limit. Yes, you could have done that, but you would still use the same function. You would still do some factoring, same factoring that you did here. You would still be able to plug in the 1 there, and you would still get a 0 as an answer. So there was no need to work that particular part of the problem. Nice problem. They love asking for missing variables on continuity. Thumbs up.